So in this video, we're going to dive into SAML, Security Assertion Markup Language. It's a standard for securely exchange authentication and authorization data between different parties. We're going to code up both SAML, identity provider, and service provider and explain what each one does. Yeah, one of the most widely used cases of SAML is a browser single sign-on, which allow users to sign in once in one place and access different applications, and it's widely used in enterprises organization where they want to manage the access of the users. So let's start by looking at the diagram that illustrates on a very high level how a browser single sign-on can work using SAML protocol. So it typically starts by user navigating to the service provider. A service provider is basically that entity that provides the service in typically in the form of the application. So let's say, I don't know, this is my email or this is my monitoring service the organization provided to me. And once user issue the authentication request to try to access the service provider, the service provider create an authentication request, a SAML authentication request, and send it back to the user browser. And then user browser sort of forward to being forwarded to the identity provider alongside with this authentication request. And identity provider is the basically the user base. It's actually responsible for keeping the users alongside with the credentials and taking care of the authentication. And it typically also have keeping the user profile information. So when the user access the identity provider, first thing that this provider does is trying to validate the authentication request to make sure that this is coming indeed from a service provider that registered before. So that's something that happens beforehand, where you need to sort of register your service provider in the identity provider. Where the service provider get assigned a unique ID that they need to include in the authentication request when they're referring the user to the identity provider. So in the next step, identity provider issue the SAML authentication response alongside some information for validation that we will look into, and send back this information to the user browser, where user browser then forwards this response to the service provider, and again service provider will go through all of those validation steps to make sure the authentication response is valid, and then if everything is was valid, it then authenticate the user and allow them to access the website. Authentication request and authentication response are primary components of the SAML protocol. So we're looking at the authentication request now, starting by these two. First, these are basically the namespace indicator for the protocol and assertions. This is going to help the XML parser to be able to parse this structure of this XML effectively, to be able to read the information. The ID is the ID of the request, is the unique identifier that is assigned to this request, which is afterwards is included inside the authentication response. The version is basically the SAML version, so 2.0. The provider name is a friendly name for the service provider. The issue instance is the timestamp where this request, when this request was issued. So the identity provider can check this to make sure the request is fresh. The destination is the identity provider login portal or SSO portal or whatever. So basically, where this authentication request is headed. The assertion consumer service URL is the URL where the authentication response must be sent to. So as you can assume, it's going to be on the service provider end. So after the identity provider issued the authentication response, then the response will be sent to this URL, and it's referred to AC, which stands for assertion consumer. The protocol bindings is the method that the service provider expects to receive the authentication response. So here we are looking at HTTP redirect. That means that the authentication response will be included as a query parameter over here, and then send back to the assertion consumer. There are other protocol bindings as well, like the post. The authentication response is included into a post request body and sent back to the service provider, and also it could be a SOAP envelope and the others. The issuers is basically this is referred to as entity ID of the issuer. Like I said, you have the service provider need to first be registered, getting registered, identity provider, and this is basically the ID to identify that this is the service provider that is registered before, and is included inside the request. And the name ID policies, this first property specifies the formats where the service provider expect to receive the name ID to identify the user. So here, as you can see, is the email address. It could be others like a username and etc. And allow create is basically specifies that if this specific user doesn't exist on the identity provider, identity provider can create a new user and send the information along. So here we're looking at an example SAML response. Again, some information about the namespace for parsing. The ID is the SAML authentication response ID, the ID of this response. The version of the SAML 2.0, the H instant, the timestamp when the response was generated, the destination. This is equivalent to the assertion consumer URL where we saw in the authentication request, basically where this response is headed. In response to is the ID of the authentication request, which we previously saw. This is the issuer is the identity provider, basically, identifier. The status is the authentication status. So the value here, basically correspond the status code of the authentication, where in this instance we're looking at the successful authentication. So then we have the assertion. This includes the primary properties that the consumer use. So again, we have ID for assertion, the version, timestamp. We have the issuer for the assertion, which is going to be identity provider. Again, we're looking at the signature of the assertion, which we're going to break down afterwards. And here we're looking at the subject of the assertion. The name ID is basically the ID of the user who authenticated, and the qualifier is going to be the service provider. And here we also see a format property which explains the format of the name ID. which in this case is transient. That means that this ID is a short-lived ID that is generated, and it's not something that needs to be tracked on the service provider side. And we have information about subject confirmation. Basically, explain how service provider should use this data in assertion. So, for example, it's this assertion is not valid on or after this specific time. The recipient going to be the assertion consumer, and is in response to the request with this specific ID, and the condition under which the assertion going to be valid, not before and not after this date, and for this audience only. And we have the authentication statement, which explains when authentication was done, the auth instance, and the expiry date for the session authentication session, and the session authentication session index. It also have authentication context class, which explain what method have been used for the authentication. So in this case, it was a passport-based authentication. It could be others, like, I don't know, certificate-based and other methods. And attributes is basically, one assertion can have 0 many attributes. So here we're looking at the unique identifier for the user, which is the value of the test, and the email of the user, which is this one. And the name format is basically explained the format of the attributes. So basic means that this is a human readable basic format for the attributes. Now let's take a look at the signature. So the authentication response signature is what service provider used to verify that this authentication response coming from the intended identity provider. Otherwise, anyone can put together a response, a XML response, and send it to a service provider and impersonate other users. And to perform that verification on a very high level, they use this notion of the digital signature, which is part of the W3C standard. And underneath the hood, it uses the asymmetric encryption, where you have 2 set of keys, a public and private key, and you distribute your key to your audience, and then you use your private key to encrypt your message, and only your audience can decrypt it, having the public key. And in this case, it's very similar. So we have, again, as the identity provider, a private key and a public key, and before sending the authentication response, on the very beginning, when the service provider try to register with the identity provider, they exchange the identity provider public key. And then service provider sort of store that public key on their end, and anytime they receive a response from the identity provider, they use that public key to verify that the signature of the response is signed by the identity provider itself. So I would like to start by explaining how this digest value was calculated. I think that's going to make easier to understand the signature itself. This digest value is basically, let's say we have the only assertion portion of the authentication response, which includes the assertion root element itself with the ID and others, the issuer, subject, conditions, authentication statement, and attributes. So we grab this whole chunk of assertion and we feed it into a hashing algorithm like, let's say SHA-256. and the result is going to be, and we calculate the digest, right? And let's say digest is going to be, some numbers like this. So digest is basically a numerical representation of a chunk of data, and any small changes that you make to that chunk, it's going to result in completely different digest. So if you change the ID or instant or anything, it's going to result in a completely different hash. So it uses commonly to validate the integrity of the data, which is exactly what we're doing here. And then afterwards, you just want to fit this into base64 encoder, and as a result, you're gonna end up with the digest value over here. So this is a reference tag that wrapped the digest value, explain how the digest value was calculated. This URI over here on the reference points to the assertion URI, meaning that the digest was calculated from the assertion. These transforms are the steps that the algorithm need to apply to the assertion, transformation that need to apply to assertion before calculating the digest. The first one being envelope signature. That means that this assertion didn't contain the signature at a time that we calculate the digest value. So this second transform is XML XSC C14N, which is a XML canonicalization algorithm. And what this algorithm does is basically normalizes the structure of the XML. So when we calculate the digest value, we always get the same result. So let's say you have misordered properties, or you have different styling and different number of the indents and etc. So this C14N a standard basically defines a deterministic way of the structuring the XML, because like I said, any small changes that you make to the assertion is going to end up to a different digest value, and that is prevented if you apply this transform first. So next up, we look at the digest method, which in this case is a SHA-256 hashing algorithm. It's the algorithm that I use to calculate the digest, and we have the digest value over here, and all of this information is wrapped in a reference. So the signature value typically generated by PKCS algorithm, which are part of the public key cryptography standard family. I think there's 15 of them, and I see PKCS 1 and PKCS 8 are the ones that used widely for the digital signature. And what you need to fit to this algorithm are basically your private key, a hashing algorithm, and a digest. So the digest is basically calculated from this signed info. Again, you're going to need to use a hashing algorithm, which is specified here in the signature method, to calculate the digest. And also before that, you need to run the canonicalization against for this signed info piece as well, which is specified here. And then you calculate the digest value for this signed info, and you feed it to a PKCS algorithm alongside the private key and the hashing algorithm, and it will result in this signature value. So the last piece of signature is this key info here. which over here we're looking at X509 certificate, which is basically your public key. So if identity provider exchange the public key beforehand to the service provider, so this over here is not necessary. And I forgot to mention that both this public key and private key are typically in the X509 format. And that means besides the information for the encryption, they also include some metadata like subject, organization, that can be used to sort of verify that signature actually coming from the identity provider. So if I want to quickly summarize the signature, we're looking at the signature info, which are explaining how what algorithm being used for the signature and what categorization algorithm need to be applied to the signature info. And we have the reference, which point to the elements in XML that need to be that we want to calculate the digest value, and also the transformation that need to be made to that element, alongside with what algorithm we use to calculate the digest. So before we jump to implementation, let's go through this diagram one more time and sort of break down each steps. So like we talked before, this authentication flow start by a service provider registering for identity provider, and in that process, identity provider basically will share a public key, the identity provider public key, and assign an entity ID for the service provider. So going forward, we assume that this public key was exchanged beforehand. A service provider can use it to verify the signature, and also we have a registered entity ID for the service provider on the identity provider side. So it all start by a user navigating to the service provider, and let's say this user want to authenticate. So they send a GET request to the service provider SAML init, which is initialize the SAML authentication flow. So what service provider need to do is to generate authentication request, which includes the ID for the request, the entity ID of the service provider, the timestamp, the binding method, and which we're going to sort of communicate, which we're going to use to deliver the request and the response, and some other information, and then compress it and base 64 encode it and send it back to the user browser. With the redirection status code 302 or 301, 302, and then the user browser going to redirect user to the identity provider. It's going to first of all land in the identity provider SSO login page. Let's say it's the IDP SSO logon. I get that sends the authentication form to the user. They need to enter their username and password, and they have this SAML request included in the URL of the login page that they landed. So when they sort of submit the page, we can extract this this query parameter from here and be included inside the request body and send a post request to the identity provider SSO logon. So then the identity provider is going to parse this request, then going to sort of validate the request in terms of request is fresh based on the instant time, and also is indeed coming from a register entity ID. They do like a normal authentication flow with the username and password. Compare the password with the decrypted password or short password that they have in the past in the user base, and then based on that they want to generate authentication response and sign it with their private key. So So this signing of the private key is part of the generating authentication response. And put all the necessary sort of information about how the digest value of the assertion was calculated, and put the signature information, like was the economic position algorithm they ran to format the XML document, and what was the hashing algorithm they used to calculate the digest. And then afterwards they compress base64 encode, because like I said, here we're dealing with the HTTP redirect binding method, and that means that the authentication response needs to be included inside the URL. In the parsing stage, we also an internet provider also excluded, extracted the assertion consumer of the service provider, and then it generates a URL like this: the service provider, SAML, assertion consumer, and the SAML response, which is base64 encoded compressed authentication responses. And then send back to the user browser, and user browser forward this response to the service provider. And what service provider does is, again, parsing and validating the response, verifying the signature, and if everything was okay, then uses the attribute statement, or I don't know, the name ID in the authentication response to allow the user to access the application. Okay, so here I am in my code editor, and like we talked about, the very first step in the authentication flow is to exchange the identity provider public key, so service provider can use it to verify the signature in the authentication response. So I have this script over here, generate X509 certificate, and what it does is creating a samples directory to output the certificate and the private key. And then I'm using OpenSSL to generate an RSA private key with the size of 2048 bits, and output to the samples directory. So because I'm having a legacy OpenSSL version installed in my system, it's going to use the PKCS1 algorithm to create the certificate. But yeah, there's also number 8 that you want to preferably use that for the production use. Then afterwards, we're creating a certificate signing request. So this is what you will hand over to the certificate authority to give you the certificate. But over here, I'm just using some random subjects for the certificate signing request. So it is going to result in the request, and then we're using the request alongside with the private key to generate a self-signed X509 certificate with the expiry of the 1 year. And afterwards we just do some cleanup, and we're removing the certificate signing request. If I run this command right now, what we get is a set of keys, private key, and the certificate, X509 certificate with the subject that we provide over here. So going forward, we're going to use this private key to sign the authentication response, and then we're going to use this certificate on the service provider side to verify the signature on the authentication response. So let's start by implementing the authentication request XML, and we're going to use the Go text templates package to implement it. And what this package does is basically it will allow you to create templates like the one that I have here for authentication request, and use this double curly bracket annotation to annotate the pieces of the template that are going to change on a variable, and then you can sort of provide these variables from outside and change it between different requests. So going forward, we're gonna have this templates directory over here, which we're going to have the authentication request and authentication response templates. And then we're going to annotate the variables and then provide the variables from outside. So for example, this is the authentication request. This is just like what we saw earlier. And what is changing from one request to another is basically the ID of the request and also the issue instant, which is the time that this request was generated. The destination is going to remain the same. It's going to the identity provider, but it's going to be identity provider SSO logon. And the protocol bindings going to be HTTP redirect and assertion consumer service URL. This is the service provider assertion consumer URL. And the rest is going to remain the same. Okay, so over here in the authentication package, we have a reference to the authentication request templates. In the templates authentication request.xml. We have the request type, which we're going to use both for populating the authentication request template and also for reading the authentication request. So the properties are ID, the request ID, and the issue instant, plus the assertion consumer service URL. All of them in a type string. And what are these annotations over here are basically for extracting data using the Go XML package. So later on, when we marshal the incoming authentication request inside the identity provider to this request type, it's going to the Go XML package is going to use these sort of properties to automatically to extract the data from the authentication request and populate these properties here that then we can use. So what it says over here is that so the ID must be read from the attributes, and this is exactly what we see over here. The ID is an attribute, and that's the same case for the issue instant and the assertion consumer service URL, which you can see over here. All of them are the attributes. So basically, this guide the XML parser to how to read these properties and put them in the request. Then we're adding a generate XML method to the request, and that, like the name suggests, this method is going to generate the authentication request XML. This first line basically reads and validates the authentication request templates, like we have it over here. And then we're going to execute, which is basically means to populate it with this request, which are two properties, basically ID and issue instant. And we're returning the result as a byte slice. So over here in the main, I created sort of a test request with the test ID and the issue instant. And the time must be in the RFC 3339, which is something like this that you see in the in this small box over here. Should be in this format. And then we get the authentication request byte slice converted to the string and printed. So if I run this, so what we see over here is basically the authentication request with the populated test ID and the issue instance, and the assertion consumer URL is going to remain constant. So that's all that's all we need for now for authentication requests. We just need to be able to generate the XML, and also we also need a way to read this. So next up is the authentication response, and here I have multiple templates created for the response, and I'll explain shortly why. So starting from this first one, the authentication response, this is basically the root elements, the root authentication elements, plus all of the attributes and some of the variables like ID in response to, which is basically the ID of the request, the issue instance, destination, which is the assertion consumer URL, and the status code, which is the authentication response status. And here we expect the assertion elements, which I created another template for it over here. So the reason that we have multiple templates is that if you remember when I was explaining how we are signing authentication response, I said that we need to sort of extract the assertion and generate the digest value, and then we need to extract the signature info and then generate the value, and then then provide the value inside the signing algorithm to generate the signature. So having these multiple sort of templates will allow us to have a more fine-grained access to these different places to generate the response. So this is the assertion response which is going to sit here inside assertion response. Is going to sit inside the authentication response. And what we have over here again, ID and issue instant, and we're going to have some attributes. And I again break down these attributes. So what we expect here is basically a list of attributes, and we're going to sort of populate this name with the name of each attributes and the value over here. So this will allow us to sort of put whatever attribute that we want and have that in the assertion response. So this assertion response is going to also contain the signature element. And this if, by the way, over here is this means that if signature element provided, put it over here. If not, it's not a problem. Otherwise, this is going to throw an error because this value is not inside the if, it's going to be required. The signature element we have it over here in the authentication response signature, which is basically the root element for the signature with the reference to the specification. It's going to require both sign info as well as the signature value. The sign info, like we saw before, we have another template for it. It's going to contain all this information for the transformation that you need to make to this sign signature info before generating the digest value using this algorithm, and the digest value itself, which we're going to sort of calculate and provide from outside. Another part of the response signature is the signature value, and this signature value is something that's coming from outside. And also, if you pay attention to the authentication response pieces that I just presented, and kind of compare it to the authentication response that we saw earlier in the video, you'll notice that I removed some of the elements. For example, there is no canonicalization transform over here, the XML XSC C14N, which was sort of responsible for structuring the XML in a uniform format, so the digest value remains the same. And the reason is that so I wanted to implement this with the Go standard library and don't install any third parties and keep it minimal. But you can imagine in a real world scenario, you want to sort of use a SAML package that also take care of all of those transformation before calculating the digest value. And in the authentication response, we have a reference to all of the authentication response templates that we just saw, the response, the assertion, the signature, and signature info. And we have the response type, which again, we're going to use this type both for reading the signature using this using the Go XML package, and also to populate the templates. So the response ID is the attributes in response to, again, an attribute. This is the request ID again, issue instance, attribute, destination. This is the assertion consumer URL. It's going to be attribute. The status code is going to be a type of a status code, which we have it here. So this is basically another type with one property, a value, which is going to be attribute. And to explain this sort of angle bracket over here, this means nested. This means like a status code is nested within the status. So if you look at the authentication response over here, this is exactly what we saw there. The status code is nested inside the status, and this is what this angle bracket means. And yeah, the status code element itself have a value which is an attribute, and then we have attributes, which is a list of attributes. And over here we have the attribute type, which each attribute coming with one name and a value. And this is what we saw inside the assertion. So we're going to use it. We're going to use those attributes over here. We're going to loop through this attribute list, put the attribute name over here, which, like we say, is the attribute of the attribute element, and we're going to use this value over here. The attribute itself is nested inside the assertion, inside the attribute statement, and inside the attribute element. So yeah, the parts are going to read it from here. Then we have the digest value, which is the string value inside the assertion, signature, sign info, reference, digest value. So we have to all the way go inside the signature info and find the digest value over here. So which is over here inside the signature info. And the last property is the signature value, which is inside the assertion, signature value. So having this response type, we're adding basically the same generate XML method to the response. And so this generate XML is going to return basically the authentication response byte slice. And it's going to be responsible for generating this authentication response, and also adding the signature to it. And like I explained earlier, we're going to need the private key, because we're going to use the RSA private key to sign the authentication response. So the private key is the argument of the type RSA private key. So we're going to start off by sort of reading the authentication response assertion template. This is this assertion over here, sort of include the attributes, the authentication statement, and over here we provide the properties needed there, which are ID, issue, instance, and attribute. So over here, what we have is the assertion, the authentication response assertion in a byte slice. So what was the reason that we sort of generated this assertion response first? Is because, like I explained, we're gonna need to calculate the assertion response, the assertion digest value, and sort of put it inside the signature. So that's the reason that first of all, like I said, we have a dedicated sort of XML template for the assertion response, and yeah, we decided to tackle it first. And over here, we're just initiating SHA-256 hash. And yeah, we are adding this byte slice, the assertion response byte slice to it, and we are generating the checksum, which is the digest value, and we encode it in the base64. And this is exactly what I described earlier in the video, where we need to sort of use a hashing algorithm to generate the digest value. And one thing I want to explain sort of going forward is that, you know, we are going to sort of skip the part of reading the hashing algorithm from the response and request. And we're going to, going forward, assume that we're using SHA-256 everywhere. But you can imagine in the real world scenario, you want to sort of extract those value from the actual response, and be able be able to dynamically change this hashing algorithm, because sometimes people use SHA-1, sometimes they use SHA-512, sometimes use another hashing algorithm. So but for the simplicity purposes, we're gonna assume always we're gonna use the SHA-256 both for the digest value and also for the signature. So yeah, we have the assertion digest value. Next up, we're going to parse the authentication response signature info, which is this one, because like I said, we're going to need this signature info sort of checksum to use for the authentication for the signature value. So we're parsing the signature info template. We put in the digest value here, which is the only variable over there. And then we have the signature info sort of byte slice. And by the way, I'm using the same sort of buffer, the template output buffer that I initiated, at the beginning of this function. And anytime when I'm sort of executing the template, I'm just resetting this buffer, so I don't need to sort of initiate a new buffer for every template. So yeah, we have the signature info byte slice with the digest value. And next up, what we want to do is we want to calculate the signature value itself. And the signature value, like I described, we're going to use the PKCS1 algorithm. This is the version of the standard itself, which is 1.5. This is the latest, I believe. So the requirement for this function is the private key that we read earlier. A hashing algorithm, which like I described, is going to be always a SHA-256 in our case, and the signature info checksum, which we generated the signature info itself, and the next step we're going to initiate the signature info hash, and we write the sort of signature info to the hash, and yeah, sort of calculate the checksum and put it here. So as a result of this function, we're going to get the signature value, which we're going to again base64 encode it. So what we have so far is the assertion, we have the signed info, we have the digest value of the assertion, and we have the signature value. So all we need to do is to sort of put all of this inside the signature. So we have this signature sort of template over here, which is going to require the the signature info element and also signature value, which we have both of them. So yeah, we have the signature elements over here. Okay. So remember that I talked about this sort of envelope. Yeah, so I talked about this envelope transform. This means that at the time that you're sort of calculating the digest value of the assertion, you don't have the signature there. So that now we want to sort of do the reverse. We want to add the signature to the assertion, and I have a placeholder for the signature element over here inside the assertion. So now what we want to do, we want to sort of generate the assertion again, but we want to have the signature over there, and that's what's happening over here. We just read we did the authentication response assertion template again, put the variables over there, and also we include the signature element over there. And so we have the assertion response. And last thing we want to do, we want to sort of put this assertion response inside the authentication response. So what we're doing here is reading the authentication response template, putting the ID respond to everything, plus the assertion response, and we're returning the byte slice. So yeah, basically, the majority of this XML code is sort of calculating the digest value and then generating the signature. So here in the main Go, if I remove this authentication request code that we just saw, what I'm doing, I'm creating the authentication response, sort of a fake one, with a test ID and test respond to ID, again time and one attribute, the username. And I'm sort of running this authentication response XML with the private key. And so we generated this private key earlier. So what I'm doing over here, I'm reading this private key from the samples, the private key. Path. Just reading it and then decode the PEM, which is the binary format. And now we have this sort of private key block. And over here, we just we're just making sure that it is indeed a valid PKCS1 private key. So we as a result of this function, we're going to have the private key. I'm just closing the file. Then I can provide this private key to this authentication response, the generate XML, which is a method dependent to the authentication response. And as a result, over here, we stringify the authentication response and just print it out. And let's see how does it look like. This is the basic authentication response root element with the test ID and IDs that we provided. And we can see over here that we have the sort of assertion, and in the signed info over here in the signed info, we have the assertion digest value, and also we have the signature value, which is a result of this the signed info plus the private key, and the attributes that we provided, which is only username in this case, the test. We're also going to need a verify signature method on the authentication response. So the service provider is going to use this method to verify the authentication response coming from our identity provider is valid. So this method is going to need the authentication response byte slice, which is the authentication response XML itself, and also the identity provider public key to verify the signature. So what we need to do in this method is basically extracting the assertion first, And that's what's happening over here. We have a regular expression for extracting the assertion root element and everything inside. So here we're finding the assertion, and we're storing in this assert B. So then what we're going to need before we calculate the digest value of the assertion, we need to remove the signature, right? But also before that, we're going to need to save the signature info, because we're going to need to calculate the digest value of that to verify the signature value. So this regular expression over here is going to extract the signature info. So we have the signature info, and then we're going to need to remove the signature from the assertion response. So this regular expression is going to find the signature element matches, and then we're going to replace this signature matches with empty string, which is basically means removing the signature from the assertion. So over here we have the assertion response. So basically, this is a very dirty way to sort of extracting these elements for verification. Again, because I didn't want to use any third-party library, but production, you want to use sort of a better way to sort of traverse this XML and extract elements you want. There are libraries like XML3 for Go that they expose a better API for dealing with such cases. Next up, we're going to need to calculate the digest value of the assertion. So right over here, we first of all extracting the digest value from the assertion response itself. Remember, like I said, we are using this sort of notation to extract to be able to for the parser to be able to extract these values. So we have these values already sort of stored inside, sort of extracted and stored in a response bar by XML parser. So right over here, we can just sort of read it from the response and base 64 decode it, because in a signature we just base 64 encode it. So we have the actual digest value on the signature, and then we're calculating the sort of digest value of the assertion response. And what we want to make sure is that we want to make sure that digest value that is provided inside the authentication response is identical with the checksum that we calculated, and that's what's happening over here in the bytes.equal does that. So if there is any slight difference between these two, this is gonna throw an error. It's going to return an error, means that the calculated value is not matching the value that is provided. And next up, we want to verify the signature itself. Again, the provided signature inside the authentication response is base 64 encoded. So this take care of decoding it, making sure it exists, and then we want to calculate the checksum of the signed info. So remember, we extracted the signature info. Now we generate we create this hash. Then we're going to use the verify PKCS1 method from the RSA package, and provide that with the public key, the hashing algorithm that is constant for us, and the signature info checksum, and also the signature value itself. So this is going to verify the signature matches this the provided public key algorithm, and also the sum. And if not, we're going to return an error over here. And this error, bad signature, I just created sort of a small type for the cases that the signature is invalid, so we can sort of return this later on the client of this method, and over there we can sort of react differently and respond differently to to the user if their signature is invalid. And for other cases, we should respond with like sort of this is our fault and this internal server error. So yeah, if the signature is basically valid, we can return nil. Otherwise, we're returning an error. Okay, now that we have the authentication package that can both create authentication request and authentication response, and can also verify the authentication response, we can move on and put together a service provider, an identity provider, and see the entire flow. So yeah, here in the routes, I created a service provider.go, and this is going to basically simulate the service provider routes that we're going to have. So we have this method over here in the service provider, in its service provider. So this is the method that need to be called to initialize the service provider routes. And what this method expects is a server multiplexer, which we're going to initiate in the main, which is going to sort of initiate this service provider, and also the RSA public key, which service provider are going to need in the assertion consumer to be able to verify the signature. And so yeah, this in this service provider basically receives the public key and sort of stores it inside this variable over here. So we can later on access the inner scope of the assertion consumer handler, and it adds sort of two routes right now. One is the service provider, which is this one, basically home handler. So let's take a look at this home handler. So all this method dot is basically sort of serving a file, and this file is SAML init template path, which is the service provider home in the templates. So I created a small HTML template for the service provider, and yeah, this HTML basically have one anchor tag, one which is a link to the SAML, to service provider SAML init. So all user can do is click in this link and sort of redirect it to this endpoint, service provider SAML init. And this is basically initializes the SAML authentication flow, which that basically means generating the authentication request, and then redirecting that to the identity provider SSL logon page. So once user generated to sort of redirected to this, which expect the GET request, it will use this handler over here, SAML init handler. So what happened inside this handler, we are basically creating an authentication request, which uses the authentication request type in authentication package that we just created, with sort of a time-based ID. So I want to keep it simple, but in production you probably can go with the UUID or something like that and store it somewhere. And the issue instant, which is the format 3339 that I pointed out earlier. And it just generated the authentication request XML. So we have the byte size over here. And like I said before, after we have this authentication request, because the bounding method is the HTTP redirect. So we want to sort of include that inside the URL and redirect it to the identity provider. And for that, we need to first of all compress the authentication request. And here, what is happening? We are using Flate, which is again a Go package, and we initialize a sort of writer, write the authentication request to it, and we extract the bytes. We sort of returns the bytes. So the authentication, this is the sort of compressed authentication request that we have here. Then we want to base64 encode the authentication request. And pay attention here, we want to use the URL encoding instead of the standard encoding. And the difference between URL encoding and base64 and instantaneous encoding is that this is going to take care of some of the characters that are not valid inside the URL, because we want to include this request inside the URL eventually. So having this result of this encoding, we're going to form the SSO URL. This is again identity provider SSO logon URL. And we're going to include the SAML request inside the query parameter over here. And then we're going to send the HTTP redirect method, HTTP redirect to the front end with a 302 code, which is temporarily redirect. So user browser going to receive this sort of URL, including the SAML request query parameter, and going to be redirected to the identity provider. So yeah, this is the init handler. Next, what we want to do, we want to sort of register this inside the main.go. So what I'm doing here, I'm reading the certificate file, the same thing, having the block, x519 parse it, make sure it's the public key, and have this IDP public key. And I imported I created a HTTP multiplexer server in the main, and I call the any service provider that we just saw, and we provided with the multiplexer instance and also the identity provider public key. Log, and running the server on port 8000. So let's just run this. Okay, I'm going to go to this URL. Okay, I'm on the port 8000 localhost, service provider home, and this is the home page. And yeah, this is the sort of anchor link that send a GET request to the SAML init. So when I click on this link, what will happen is that it will redirect me to the identity provider SSO. We have the SAML request inside the query parameter, and this is base64 encoded compressed SAML request. So next up, what we want to implement is this identity provider SSO logon page. Okay, on the identity provider, we also have init identity provider method, which again, we're going to need the multiplexer and the private key. We are receiving the private key stored in a variable, so we can access it in a signature scope. And we have sort of two handlers over here. The first one being this SSO, which being handled by SSO handler. And all this method does is basically returning the SSO HTML page, which is this page over here, idp_sso.html. So I created this HTML sort of file. And what we have over here, we have a sort of authentication form with a username and password. And once user click on this login, we have a small script over here that says, listen to the submit event of this form. Prevent the default, that means like do not refresh the page, which is the default behavior of the form. We are getting the search parameters, and from the search parameters we are extracting the SAML request. So we have the SAML request inside this query parameter. And besides that, we are, from the form data, we are getting the username and password, which are required. And then we're sending a post request to IdP SSO logon, which we are going to also implement. So what is logon? And we're sending the username, password, and SAML request inside the request body. Waiting for the response. If it wasn't okay, throw an authentic error. And if it was okay, the response is going to be, a text. In the text format, it's going to be only redirection URL, which we're going to change the the location to that redirect URL. That means like sort of redirect to that URL provided by authentication, provided by this IdP SSO logon response. And this URL is going to be the service provider assertion consumer URL. So now let's go back to the logon. So like I said, this first method is going to return this page, and this second handler, SSO login handler, is the one that they're sort of waiting for the for this SSO page to send the post request with the username, password, and authentication response. So here in the login handler, first, like we're doing some basic validation, authentication validation. So this arbitrary check. We sort of extracting these elements from the body, making sure it's a JSON. I have this logon request sort of type that sort of extract the username and password and authentication response, which coming in a SAML request property. Making sure there exists, and if there exists, go forward. If not, just return the error. So here we don't do any sort of actual authentication, but in a production environment, what you want to do, you want to sort of query your user base and at least compare this password against their hash password, decrypted password, or whatever, and then move on with the authentication request. So what we need to do with the authentication request is basically the reverse of everything we did when we were sort of creating the authentication request XML. We first need to base64 decode it, again using the URL encoding. Having the decoded authentication request, we need to decompress it using the same compression algorithm, plate. We decompress it, and then we have the authentication request. So byte slice over here, and we're going to use the the request type that we created, that we can see over here, to sort of read some of the properties coming from inside the request. We're going to let the XML parser to extract this, which is ID, issue instance, and assertion consumer URL. So right over here, I'm jumping and getting the sort of ID of the request and assertion consumer, and I don't really do any other check, like checking if this ID of the service provider is like registered before or is not a registered identity provider. This is something that you need to do. There are cases that you need to check the freshness of the request, so you can use the sort of time instant, issue instance of this request, and sort of make sure that it's not expired or something. And then after that, you want to use the assertion consumer service URL. There are identity providers that sort of validate that this assertion consumer URL is matches the one that they have in their database, which is registered by service provider before. So over here we have the ID and assertion consumer. We sort of store this ID in this one too, and assertion consumer URL inside the assertion consumer URL in the AC URL. Next up, we want to create the authentication response. again, create an arbitrary ID for the response in response to the authentication request ID, the issue instance. The destination is going to be assertion consumer URL. The status code over here is successful. So this is the this is the format that they use in SAML. Is they indicate that the authentication was successful, and we put in some attributes, which over here I'm sort of whatever username the user inputs, I sort of put it here and send it to the service provider. Then we want to generate the XML of the authentication response, and remember this XML include the signature as well. So then we want to sort of compress this like we did with the request using Flate. Having the compressed authentication response, we want to base64 URL, again, encoded using the URL encoding. And then we need to return this request back to the front end, right? So we have the assertion consumer URL, which include the assertion consumer URL provided by the request in authentication request, and also SAML response, which is base64 encoded compressed authentication response like we saw. Yeah, adding the sort of text plain content and then returning this to the front end. And what front end does, again, identity provider SSO, it receives this response, parse it, and then sort of redirect the user to that URL. So user from here is going to go to assertion consumer URL on the service provider. And in the URL, we're also going to sort of include the authentication response. So next up, I need to register this in the main.go, like we did with the request. So I'm just reading the identity provider private key here, and make sure we parse it with the X509 PK CS1 parser, and then over here I'm calling the init identity provider. I'm provided with the mocks and IdP private key. So next up, I want to restart the server, and I'm gonna go again to the service provider. So here I'm on the service provider again. So I'm going to initialize the authentication. We've been forwarded to identity provider SSO page with the SAML request. In the query parameter, I will be asked to put a username and password. I'm putting storage period over the username and some password. So when I click login, I expect to be redirected to the assertion consumer on the service provider with a SAML response. And so it was redirected to the assertion consumer, and we have the SAML response encoded inside the URL. So next, what we want to do is implementing the assertion consumer. Okay, back to the service provider route. I added a new handler for assertion consumer, which any request coming to the SAML assertion consumer is going to go to this SAML assertion consumer handler. So this method, basically what we want to do, we want to sort of receive we want to extract the SAML response from the query parameter. We want to decode it and verify the signature. And if it was valid, we want to return back the sort of attributes inside the signature to the user. And in a real world application, you want to authenticate user and let them access the application if everything is valid. So, and that's what's happening here. We have the encoded authentication response that we are getting from the SAML response query parameter. Then using the URL encoding, we decode it. So we have the assertion response byte slice. So remember, it was compressed. Then we use Flate to decompress it. We have the authentication response. Then we want to use the authentication response type, which we have over here, with all of this XML sort of annotation that guides the parser to extract the information that we need. So yeah, we just use the XML on Marshall to read from this byte slice and put it inside this authentication response that we initialize. And then what we're going to do is to call the verify. I remember this verify verifies the signature inside the authentication response, doing all of that interaction and calculating the checksum of the assertion. So yeah, and we provided with the identity provider public key. We don't have the private key on a service provider. We have a public key and we use it to verify the signature. And if it was valid, we will proceed with the parsing sort of HTML file that I created, which is this one, templates service provider assertion consumer HTML. We have it right over here, and all this does is basically shows the status code extracted from the assertion from the authentication response, and also it loop through the attributes and show the name and value of each attribute. We sort of skip a couple of checks here. For example, checking the entity ID of the identity provider, checking the sum of the condition provided authentication response, like what is the expiry date, and checking the session ID. Those are potentially you can put some extra check over here to make sure this is the legit request. So over here we only pretty much verifying the signature and then trusting the response. Then I'm returning back this HTML, which I populated with the status code and attributes. So I'm going to just restart the application again. So if we go to the service provider, here I am with in the assertion consumer URL with the SAML response. So if I just refresh this page, we get the status of the response and also the username. So let's check one more time. If I go to the service provider, I can initialize the request. Go here, put some username and some password. Redirect it to SAML assertion consumer with the authentication response. And here we have the status, which means successful, and also that's all I wanted to cover in this video. I'm going to post all of the links in the description. If you found it useful, please like and subscribe so YouTube feature to more people. And yeah, see ya.